Hello students, I am Kirti from Computer Science Department, GSIPU College, Mysuru. So in the previous session we have studied about the applications of queues as well as the program for NQ and DQ operation of a queue. In this session we are going to study about the concept called linked list. So why do we need a linked list when we are having an array? So an array is of a static structure. So in array we cannot increase or decrease the size of an array. When it comes to the insertion of an element into an array, the position of an element is increased to its higher position, and while deleting an element from an array, the position is reduced to its lower position of an array. So to overcome this disadvantage, we are going to use a concept called linked list. So linked list is a dynamic structure. So in today's session, we are going to study about another data structure called linked list. So in linked list, it uses dynamic memory allocations. So now let's see what is a linked list. A linked list is a collection of data elements called nodes, and the linear order is given by using pointers. So what is a linked list? A linked list is a collection of data items, data elements called node, and the linear order is given by using pointers. So what is a node? So a node contains two parts. So this is called as a node which contains two parts. So this is the data part and this is the link part. So this data part contains the information and the link part contains the address of the next node. It contains the address of the next node. Consider an example. So this is the start pointer which contains the address of the first node. So this node has two parts. In the first part it contains the information, and in the second part is the link part which contains the address of the next node. So this next node contains an element called 20 and the link part contains the address of the next node. So in the third node, it does not have any link to the next node, but it contains as null. So this represents that the end of the node. So here the start pointer is also called as head pointer. So why do we require this head pointer means, for example, the address of the first node may be 1022. The address of the second node may be 1032. And the address of the last node may be 1001. So while seeing the linked list, we can say that a linked list is where the elements are stored in a contiguous memory locations. But these nodes are physically contiguous, but they are not logically in a contiguous memory location. So for that we require head pointer. To access all the nodes in the linked list, we require this head pointer. So now let's see the different types of linked list. Types of linked list. The first type of linked list is singly linked list. It is also called as SLL. In singly linked list, it contains a header point. So this header point contains the address of the first node, and this first node contains two parts, data part and the link part. This data part contains the information of the element, and this link part contains the address of the next node. So in the second node, if the link part contains null, it represents that the end of the linked list. That is, it does not contain any other node. Since there is only one link field in all the nodes, this type of linked list is called as singly linked list. The second type of linked list is circular linked list. Circular linked list, which is also called as CLL. So in circular linked list, in singly linked list, it contains only one link part in each node. So in singly linked list, we have the link for the successive node, but we don't have link for the preceding node. That is, we cannot come back to the previous node. We cannot access the previous node. So to avoid that, we are using a concept called circular linked list, where in circular linked list, first it contains the head pointer, which contains the address of the first node. The first node contains the address of the second node, and the last node does not contain null in the link field because it is referring to the first node of the linked list, because it is referring to the first node of the linked list. So using circular linked list, we can traverse to the any node in the list. That is, the last node is linked to the first node of the linked list. Next type of linked list is doubly linked list. What is doubly linked list? So in doubly linked list, a node contains three parts. It contains three parts. The first part is the back pointer, and the second is the data part, and third is the forward pointer. Forward pointer. So this back part contains the address of the previous node, and this data part contains the information, and the forward part contains the address of the next node. So in the doubly linked list, it contains a head pointer, which is also called as the start pointer. It contains the address of the first node. So this first node contains three parts, that is a back part, data part as well as the forward part. So this if the back part contains null value which represents that, so this is the first node of the linked list. So in the data part it contains the information and the forward part contains the address of the next node. Contains the address of the next node. So in the next node, the first part, that is the back part, contains the address of the previous node, and the second part contains the information, and the third part contains the address of the next node. So in the third node, the back part contains, that is the back pointer contains the address of the previous node, and the data part contains the information, and the last, that is the forward part, contains the value called null, which represents that the end of the, which represents the end node of the linked list. So this is about doubly linked list. So what is a linked list? A linked list is a collection of data items called node, and linear order is given by using pointers. So what is a node? A node is where it contains two parts, that is data part as well as the link part. So this data part contains the information to be stored, and the link part contains the address of the next node in the linked list. So the types of linked list, that is there are of three types: singly linked list, circular linked list, and doubly linked list. In singly linked list, so each node contains only one link field. Such type of linked list is called as singly linked list. So in singly linked list, we cannot access the previous node. So to overcome that, we are using the concept called circular linked list. In circular linked list, the last node is referring to the first node. So it contains the address of the first node of the linked list. So such type of linked list is called as circular linked list. When it comes to doubly linked list, so here each node contains three parts, that is back part, that is back pointer, data as well as forward pointer. So this back pointer contains the address of the previous node, and this data part is where we are going to store the information, and the forward pointer contains the address of the next node in the linked list. So this is about linked list and the types of linked list. Now let's see what are the operations we can perform on linked list. So on the linked list, we can perform operations like creating a linked list, traversing the linked list, insertion of an item into the linked list, deletion, searching of an item in a linked list, as well as merging of the linked lists. So the operations, what are all the operations we can perform on linked list? We can create a linked list, creating a linked list, traversing a linked list, third one is inserting an item into the linked list. Deletion of an item, that is deleting an item from the linked list. Searching an item in the linked list. Sixth one is merging of two or more linked lists. So these are the operations what we can perform on linked list. Now let's see how to create a linked list. A linked list is a linear data structure where it contains a group of nodes and each node contains two parts, that is the data part as well as the address part. So the data part contains the information to be stored and the link part contains the address of the next node. So here the start pointer contains the address of the first node in the linked list. So why do we call linked list as a linear data structure? Because the nodes in the linked list are linearly arrayed. That's why we call it as linked list is a linear data structure. So now let's see how to create a node. So while creating a node, first we have to know that the node contains two parts, that is data part and the link part. So data part contains the information. For example, it may store only the numbers. So the data type will be the int. When it comes to the link field, it contains the address of the next node. So as it is a pointer type, so here the data types may differ. So in this case, we can think of a structure concept. So struct is a keyword and node is the tag name. So we are creating data field. So the data type is int as well as the link field, as it is a pointer to the node. In C++ we can simply write it as node star link. So here we are creating another two nodes of type structure, that is node star node 1 comma star node 2. So these are all the pointer to the structure. So in this declaration, so here we have declared two structure variables. Each structure will be taken as a node. Thus, it is a linked list with two nodes. If I want to add another node, it is not possible because we have already declared only two nodes here. Also, there may be some cases where the memory needed is only determined during runtime. So in these cases, program need to be dynamically allocate the memory using the operator called new. So this new operator allocates space and this new, so this operator new will allocate memory locations for arrays. So this new operator is followed by the type specifier. Pointer is equal to new type number of elements. So this first syntax is used to allocate memory for one single element. And this declaration, the second declaration, is used to allocate memory for the list of elements. We can also call it as an array of elements. So to delete the elements, we are going to use an operator called delete as well as delete. So in most cases, the dynamically allocated memory locations used only for in some particular time. So after usage of those memory locations, if it is no longer needed, we can release those memory locations for the further usage. So that can be done using the operator called delete. Delete pointer, delete. So this first declaration is used to delete the memory location of a single element, and the second declaration is used to delete the memory location for the list of elements, that is the array of elements. So this is why we use a pointer new as well as delete. Pointer new is used to create a new memory location, and delete is used to delete the dynamically allocated memory which is no longer needed. So this declaration is used to allocate a memory only for single element, and the second declaration is used to declare the memory locations for the list of elements. While deleting, the first declaration is used to delete the memory location of a single element, and the second declaration is used to delete the memory locations allocated for the array of elements, or we can call it as the list of elements. So now let's study about the second operation, that is traversing of a linked list. What is traversing of a linked list? So what is the meaning of traversing? Traversing is nothing but the process of visiting each node of the linked list exactly once is called as traversal. So to traverse all the nodes in the linked list, we have to follow the steps. To begin with, move to the first node. See, this header contains the address of the first node, and this contains two parts, that is data part as well as the link part. So data part contains the information and the link part contains the address of the next node. So to begin with, we have to move to the first node, fetch the data from the node and perform the required operation based on the data type. Advance the pointer to the next node. So step 2 and 3 should be repeated until all the nodes are visited. So now let's write an algorithm for traversal. So this is the algorithm for traversal. So here the start contains the address, start contains the address of the first node, data contains the information, and link part contains the address, of the next node, So what is the first step? First step, to begin with, we have to move to the first node. That is, here P is the temporary pointer to visit all the nodes in the linked list. So P is equal to start. Step 2, while P does not is equal to null. That is, if the first node in the link part, if it does not contains a null, then we can fetch the data of that node. Step 3, process data. Process data. So in the step 4, we have to link the node to the next node of the linked list. So that is P is equal to link of P. We have to link the next node to the previous node. Process should continue until we visit all the nodes of the linked list. Step 5, end of while. Step 6, return. So while traversing the nodes, the linked list, first we have to move to the first node. Let the P be the temporary pointer to visit all the nodes. So until the link part of the node does not contain null, we can visit all the nodes of the linked list. While visiting the node in the linked list, we can fetch the data and we can perform the operation based on the data type. And next, in the link part, we are going to link the next node in the linked list. So until we get the null as the link part in a node, we can traverse all the nodes in the linked list. So after, when we get the null in the link part of the node, we have to stop traversing. So this is about creating a linked list as well as the traversal of a linked list operation on linked list. So in the next class, we will continue with the other operations of the linked list. Thank you.